We're expressing products as sums and differences for sine and cosine terms. So we're going from products to sums or products to differences. And we can see a summary here. So the three we have a summary of them: 2 cos A, cos B, 2 sine A, sine B. So this one has both coses, this one has both sines, and when we have one of each there, and it doesn't matter which way around that one goes. And where do they come from? Well, we've done some work on identities for angle sum and angle difference for sine and cos, and it comes from actually there. So basically we can look at where each of these come from. So you're familiar with these below. So the first one here is achieved by looking at below the second one plus the first one. If we look at that, so it's, if we use those numbers from below, the second one from the angle sum and difference identities plus the first one, and you can see that if we do that, we'll have these two terms which are the same. There'll be 2 lots of them, hence we get that. 2 lots of cos A, cos B, and these ones here are equal and opposite in sign, and they'll cancel each other out essentially. So then you'll have these added together on the right hand side, cos A plus B and cos A minus B, as you can see there. So they're all just they all emanate from a combination. So the second one here comes from 2 minus 1, we could show, and the third one comes from 3 plus 4. Now these will be on a formula sheet for you if you're in my class, so you don't have to remember them, you just have to understand that they can vary in the way they look. For example, I'd like to show you that this one here could be written as cos A cos B equals a half of cos A minus B plus cos A plus B. So you can see that's the same thing. So basically instead of the 2 there, it's halved, it's down to 1, and so you have to halve the right hand side. So essentially it's the same thing. Alright, so they're not things that you have to remember verbatim, but you know that they come from the angle sum and angle difference identities for sine and cos. We see an example down the bottom of the screen there: 2 cos theta plus pi on 4 times cos theta minus pi on 4. Express this as a sum or difference. So we should get something on the right hand side. So we need to work out what do we have from the left hand side and use the appropriate identity correctly. So let's have a look at this here. So 2 cos of something, cos of something else. So we have the cos and the cos. It might be the first one here. Let me clean this up. So let's check, do we have 2 cos A, cos B? Well, that would mean A equals theta plus pi on 4. That's an angle. That's fair enough. And B is a different angle? Yes. So theta take pi on 4. That seems like a reasonable hypothesis to get started on. Now if that were right, when we get over to this right hand side, we've got to get the first angle and subtract the second angle, and then there we've got to add them. So let's look at what that would be like. So we've got A plus B would be theta plus theta, that's 2 theta, and then pi on 4 plus negative pi on 4, which is 0. And we would have A minus B would be theta minus theta, and then pi on 4 minus negative pi on 4, which is pi on, that's gotten a bit untidy there, so it's pi on 4. Let me just explicitly show that one. Pi on 4 minus negative pi on 4, because This one here has a negative sign on it, SIGN. So it's pi on 4 plus pi on 4, which is pi on 2. So let's have a look at how that goes. We can see a minus b there, and we can see a plus b there, and that would make cos of, does it follow the pattern? Cos of a minus b, cos of a plus b, does that follow the pattern? Let's check back up there, cos a minus b, a plus b, yes it does. Alright, and then looking at what we've got here, we can simplify that further. Let's have a look at how we get from this second last line to the last line. What is cos of pi on 2? Cos of pi on 2 is 0, so it's just cos 2 theta fully simplified. Okay, so that line is a reasonable answer. That line is the best answer because remember cos is the horizontal aspect, and when we rotate the pi on 2 it's 0.